Okay, in this video, I'm going to go ahead and pick up where I left off in my last video, which was just showing some color bands as I output on my VGA circuit. So let me go ahead and get my system fired up here, and flip on power. And we start with the snow, just the uninitialized VRAM, and then you can see the color bars. Now, a couple of things I want to point out right away is I am now going out of my VGA output into a VGA splitter. One end of the splitter is going to this LCD screen that you see over here, and then I have another output going into my computer through an inexpensive HDMI to USB capture device. And then that's what's being displayed here inside of OBS. And I'm also recording that as a separate basically camera that I can pull into my editing as I put together this video. Let me get into maybe the next things I want to look at. The color bands are great and all, and this allowed me to go through and just test each of the bits, other than there's one red that doesn't fit on the screen, but I have 15 segments displayed on the screen here. And I have, an increasing value of brightness in my blues and my greens and my reds. And that all seems to be looking okay. And I can hit F12 and toggle back and forth between those two frames. I can come in here and type in, and that all seems to be working fine, just as I showed it in the last video. But I want more than those bars, so maybe let me show you what we can take a look at here. I am going to use an image, a source image that looks like this. I basically grabbed two different images. I wanted something that I could test that would be fairly difficult to produce nicely, and the bottom of this, especially with this just continuous gradient, that's really hard to do with a lower number of bits per pixel on your VGA card. And so the first thing I did is I took an image and I resized it to 640 by 480, and then I put it into a 1024 wide format, just because my video memory, actually I'm only going to use 640 wide. So basically the way it's going to work is I have 2 bytes per pixel, so it's going to take up 2K basically to work across the screen, the full 1024 wide. I'm only going to use 640 of it, but I can't stop. I need to stop at a power of 2, so I either stop at 512 or 1024. 512 is not big enough, so I have to go to 1024. Being that there's 2 bytes per pixel, that's 2048, so 2K of data per line. And that's how my memory is organized. What you're seeing then on the image on the right is fitting within that nicely, so that I can just read the raw data out of here and write it out to my VGA. And I have looked at ways of making that all contiguous and not have that black space, but then there was some good online discussion that maybe if I'm going to at some point try to do hardware scrolling as an example, this is more of how we probably want to set it up. So I'm going to leave it like that, and that's how I'm going to work with it for now. So I want to get that image on my screen, on my output. So I have a little utility, and I did an image conversion just down to an 8-bit. So I took it from the source file, which would have had 24 bits of color plus 8 bits of transparency data. But I converted it down to 8-bit. So I compressed all that color data, and I could kind of see a preview of what that looks like. And you can really see this. These gradients are pretty tough to do with 8-bit color. You can see that this face, you start to see sections, it's not a nice blending like you see up here. So I added a little support to my image converter to do a 16-bit conversion, since I now can support 16-bit color. And you can see it looks better now. And so this is the original source. This is now a 16-bit compressed version. So my utility just basically says, okay, you've got 8 bits for red, 8 bits for green, blue, etc. Take those 8 bits and compress it down to 5, 6, or 5, depending on if it's red, green, or blue, as far as how I've set up my output. So I've got 5 for red, 6 for green, 5 for blue. And so I'm doing that compression down to 5, 6, 5 from the 888. This utility then lets me save a ROM, and it actually writes out a file then that has all the image data that maps to what you would see down here in the lower right image. And the actual image data there is 600K, the full frame of what you're seeing here would be a full meg of data. So that's what I am working with. I have now basically a meg of data that I have to somehow get into my video RAM from a computer where its entire address space is 1 megabyte. So that's a little bit of a challenge. As far as my 286 is concerned, I have a meg of physical memory, but only 640K of it is accessible. My ROM is taking up 256K. My VGA window basically is 64K, and then I have 64K that's available at the moment. So what I thought I would do, the solution to that seemed maybe pretty obvious on my build, at least for me, is to try using the SD card. So I have on this SD card that's in this SD card reader, I think it's an 8 gig file, or 8 gig SD card as far as capacity, but I copied over that 1 meg file into the SD card. No file system, anything like that. I copied over the raw data at the beginning of the SD card. For all practical purposes, I'm treating it like an 8 gig ROM file, and that's how I'm accessing it for now. But I now have my data here that I can load up into my computer. And I've added support that if I hit F5 on my keyboard, it's going to go through and get all of that data pulled into video memory. And you might notice as I'm talking over here, these bar graphs on the right, remember the 5th LED in, I mentioned this in my last video, shows which frame I'm actively working on. And then the video output would be the opposite frame. The 4 bits to the right of it show which page of memory is the 286, which frame buffer page is it using, plus those 4 bits to the right will show me which of the 64K segments within is the 286 currently working with. And you can see it slowly working up. Basically what I've got it doing is through serial, I'm bit banging out to the SD card, I'm fetching all that data, and I'm getting it all transferred into the video RAM here. And that's not a super fast process, but it is coming across. I think I have a ton of optimization I can do there. I'm not worried about the speed right now. I'm really more worried about the testing. Can I get this to work? And then you'll see now on my output, I am getting that graphic. And I'm going to also flip over to OBS so I can see it on my screen here at the same time. So there is that, and if I pull up the original image at the same time, that's what the original image looks like. So that's the original image that was compressed at least down to 16-bit of color. To the right is what my VGA card is actually rendering it out as. And I can still toggle between the frames, and so if I go I just hit a key that's going to actually load it into the other frame at the same time. So I initially populated one frame, now I'm having it populate the other frame, and I can see that because over here that 5th LED is off, so I'm on a different frame than I was before, and I'm cycling through the 64K segments right now. But once that's done, I'm going to toggle back and forth between those two frames, and you'll see that there are definitely differences in output quality between the two frames. And like I mentioned in the last video, that's probably due to ICs, and the wiring is different lengths to get to different locations on this. Maybe while that's doing that, I will comment to these resistors I've been playing around with, and at the moment, these resistors that pull down to ground, I've dropped those down to a 15 ohm resistor. And I had done that to really make the colors match. And what you're seeing on the screen already, you can see the colors, in my opinion, are pretty darn close. They're not bad for, you know, the yellow, the blue, the red, the green, what I would expect to see. It's close enough. I'm not great with colors, but it's pretty darn close in my opinion. Okay, at this point that frame is loaded, so I should be able to toggle between the two. So there's one frame output, there's the other. And you can see there's definitely some differences. One's a little bit darker. You can see if you can see the difference, and if there's one of those that you think looks better than the other. But at this point though, what I did is that image was pulled off of here. I put it into this VRAM. Actually, the first time I did it was down here to this frame 1. And then I swapped and I did the whole copy process again. I copied it over here. So now both frames contain the image that you see on the screen. And then I can toggle between the two. So at that point, I really am showing a couple of things. One is I am now treating the screen as a full frame, not just as a series of 64K chunks. And I'm able to read my data, get to the appropriate location on the screen output, and then display it. Would also take a look at the output and see that I do definitely have this kind of some banding here, or some, you can tell where it's just not a real smooth. But I think I can play with these resistor values if I want to make that a little bit better. I'm not worried about it, quite honestly. I'm quite happy with this output, and like as I look at the face, the eyes there, that all looks good. I don't see anything there that is a concern to me. And so that's probably what I'm going to run with for now. Maybe down the road I can come in and adjust these. So if I wanted some bigger differences in some of the blues, or some more subtle differences in some of the steps between blues, I can play with those resistors and try to dial that in a little bit. But at this point, at least now I know I can load a full meg of video content off of the SD card into memory, get it pushed out to the VGA output. And I think the next thing I need to now do is try to get some type of animated content where I'm programmatically toggling as fast as the system will go between the two different frames. And we'll see what that might look like in an upcoming video.